Hello guys, today let us learn about the difference between load and store operations which is going to be carried out in an ARM. So we are knowing that ARM is under an RISC architecture, reduced instruction set architecture. So it is going to have only load and store instructions. So whenever you are going to perform any of the operations in an ARM, you need to understand what is load and what is store. So that have been formulated here. So load means it is going to take the content present in a memory. So the memory means it is in stack memory. So whatever the content present in the stack memory is going to be stored into the register. So this operation is called as an load operation. So if you are going for a store operation, so if you need to push any of the results from registers to an stack memory, so if you are performing any of the sum or any of some kinds of an operation, so that will be stored in an registers. So these register values is going to be pushed into an stack memory. In order to perform this, we are going to make an operation called as an store. So let us see this load and store instruction one by one. So first we are going to see what is this load instruction which is going to happen in an ARM. So this ARM is going to have an specific kinds of an versions. So for all the versions of an ARM, so this load and store is going to be get same. So let us see the syntax. LDR stands for, and short form of this load instruction, LDR means load instruction is going to be get operated. So RN is our destination register. So RM is our is the base address register. So it is an base register. So the value present in RM is used to point the stack memory address. So in a basic simple words, RM stands for, so this RM stands for base register, which is going to hold some value. So that value is going to act as a pointer to point the stack memory to the exact pointer, to the exact position. So the stack will be divided into number of sections. If you need to point to the specific memory location, you need some address value. That address value is going to be stored in RM. So this big brackets is going to tell that go to the address of that respective base register value address and take the content and take the data present in that address, store that data to the RN register. So this is the technical meaning of LDR RN comma square brackets RM. So RM is your base register. Base register is going to point to the exact location in your stack memory. So if this is confusing, I am having some of the example here. Consider this is my stack memory. For an example sake, I have been started the starting address of the stack from 400000000 to 4FFFFFFFF. So this is my example here. LDR R1 comma inside the square brackets R2, mean to say content of R2. Let's consider the value of this R2 as 4000004. So this is the value which is going to be present somewhere in a stack memory. For our example sake, we have been made the stack memory starting from 40000 to 4FFFFFF. So this value present in R2, which is going to act as a pointer. Pointer is the one which is help in pinpointing the exact location. So this R2 value is used to point the address which have been present for an each segments of the stack memory. You can see here for each segments the specific address have been provided for your stacks. For this n number of address, you are interested with specific 400004. So for pinpointing any of the specific number or a specific address location, you are going to load that into an RM register. Here RM is replaced with R2 register. So this R2 register is going to point where this 40004 is going to be get located. So first wait a second. So this R2 is just going to point the location inside the stack memory. It is going to just point the location inside the stack memory. It is used to point inside the stack memory and later it return backs. So after getting the pointing, so the compiler is going to fetch the content of this address. So the square brackets tells that go to the content of this address. For an explanation sake, I have taken this data 100. So this 100 is going to be get stored in this R1 register. So this 100 is going to be get stored in this R1. So this is the exact operation of your load instruction. So R2 is going to hold the address. So this address is used to pinpoint the address location of an stack. So here it will be just an value. So this value is going to be pointed the stack memory. So the square brackets indicates that what are all the content present in the stack memory address, take that content and store that content into an destination register. Here my destination register is R1 register. So this is all about an load instruction. So we have been started with specifying the address in the n number of stack address. So this is having many segments of stack address. Inside this n number of stack address, we are interested with 40004. So this R2 is going to hold just an value. So this value has been taken as a pointer to point the exact address location inside the stack memory. So the content present in this, is going to be get accessed and it is going to be stored in an R1 register. So hence we are going to tell that we are going to have an loading of an data which is present in an memory. So this is my stack memory. So this is my stack memory. So this stack memory content is going to be stored into R1 register. So this is all about load instruction. So let us see about an store instruction. So this is store. So the store is the exact inverse operation of an load. So what are all the content present inside the register, it is going to be stored into the memory, that is stack memory. So the content present in the register is pushed to the stack memory, and this is my syntax. As load instruction, str stands for store. You are going to perform store operation here. Str space rn comma inside big brackets rm. So here rm is again an base register which is going to point the address location to where this rn content is to be get stored with. So again this is some of the value. It can be anything. It can be 400012. This is for explanation sake. So it can be anything. So this, by making use of this value is going to point the stack memory So with that specific address, the content present in an RN register, it is going to be get stored. So for an example sake, this explanation, store R1 comma content of R3. For an explanation sake, I am taking R3 as 40000012. So this is the address location where I have been interested with. So let me explain with a figure. Let me consider R1 is having a content here. So R1 is having a content called 400. So this 400 should be stored in a value pointed by the R3 register. So this is just a value which is pointed by the R3. So this value is going to be pointed in a stack. So after pointing, the R3 job is over. So later R1 content is going to be stored in the address location pointed by the R3. So this is my address location. So here my 400 is going to be get stored once we are going to execute this instruction called str. So this is all about how we are going to make an load and store instruction. So the content 4000 is going to be get stored by the address, stored by the value pointed by the R3, and this R3 is going to point that exact address in a stack memory. By making use of that address, we are going to store our data into that respective position. So the content present in R1, is going to be stored in this position. So this position is pointed by R3, and this whole process is explained here. So this is all about a summary of load and store instruction. So which is usually happening in all the RISC processing devices. It can be controllers or processors or anything. So all the RISC processing capable devices are going to follow this load and store architecture. So this is the overall working of an load and store. Please subscribe and support for more videos on LPC 1768.